Hello, my name is Gabrielle Clark, and this is my senior project on Bretschneider's formula. Bretschneider's formula is used to find the area of a general quadrilateral. Over here at the top left, I have the formula highlighted in gray, as well as an image of a quadrilateral that we are going to use to derive the formula. S is the semi-perimeter, which we will need for the formula, and it is a plus b plus c plus d, which are the four sides, all divided by 2. I also have some additional theorems and calculations that we will need to derive the formula. To begin finding the area for this quadrilateral, I have drawn a dotted line between angle D and angle B in purple to split the quadrilateral into 2 triangles. We will then use the 2 triangles to start out our equation. So to begin with our area, we have the area of the quadrilateral being equal to the area of triangle ABD plus the area of triangle BCD. And then using basic area formulas and some trigonometry, we know that the area of triangle ABD is equal to 1/2 times AD times sine of alpha. And that the area of triangle BCD is 1/2 BC times sine of beta. Okay, so now I'm going to multiply our area formula by 4 and then square it so that we can continue deriving our formula easily. So I have 4a equals 2AD sine of alpha plus 2BC sine of beta. Then when we square that 4a, we will square this entire thing, and then we will have to FOIL. Quantity 4a squared is equal to 16a squared, and then when we FOIL on the right, we get 4a squared d squared sine squared of alpha plus 4b squared c squared sine squared of beta plus 8abcd sine of alpha sine of beta. So now I will use the law of cosines to come up with an identity to add and subtract to the right side of this equation. So starting with triangle ABD, we know that a squared plus d squared minus 2AD times the cosine of alpha is equal to our segment DB squared. Now I'm going to apply the law of cosines to triangle BCD, and I get b squared plus c squared minus 2bc times the cosine of beta is equal to segment DB squared. Now since both of our equations equal DB squared, we can set the two equal to each other. And then if we move some things around, we get a squared minus b squared minus c squared plus d squared is equal to 2AD cosine of alpha minus 2BC cosine of beta. Okay, so now we are going to bring our 16a squared down here, and we are going to add and subtract the identity that we just found. but we are going to square each of them. So we are going to add the right side squared. So plus 2AD cosine of alpha minus 2BC cosine of beta squared, and subtract the left side. So we have a squared minus b squared minus c squared plus d squared all squared. Okay, so now I'm going to FOIL out this piece. And when I do that, I get all of this plus 4a squared d squared cosine of alpha squared plus 4b squared c squared cosine squared of beta plus 8abcd cosine of alpha cosine of beta. And then at the end, we'll just bring down the minus a squared minus b squared minus c squared plus d squared all squared. Now there are some things that I can combine. So I have my 16a squared still on the left, and then I can combine my 4a squared d squared sine squared of alpha and the cosine squared of alpha. I can also combine my 4b squared c squared with the sine squared of beta plus cosine squared of beta. And then I can also combine the 8abcd sine alpha sine beta with the cosine alpha cosine beta. And then still am bringing the a squared minus b squared plus, or minus c squared plus d squared all squared down. So now we can use a couple of our trig identities. So from the Pythagorean identity, we know that sine squared alpha plus cosine squared alpha is 1, and also sine squared beta plus cosine beta is 1. We also know from the sum and difference of angles that this right here is equal to the negative cosine of alpha plus beta. So now if I rewrite everything, we have 16a squared equals 4a squared d squared plus 4b squared c squared minus 8abcd cosine of alpha plus beta, and then we're still bringing down this last piece. So now we are going to add and subtract the same thing again, but this time we are going to use the 8abcd. So when I do that, I get 16a squared equals 4a squared d squared plus 4b squared c squared plus 8abcd minus 8abcd, and then I can combine the two negative 8abcds, and I will get negative 8abcd times 1 plus cosine of alpha plus beta, and then I will still carry down the negative a squared minus b squared minus c squared plus d squared all squared. So now I can use another one of the trig identities for this piece, the power reducing identity. If I just move it around a little bit, I will get that 1 plus cosine of alpha plus beta is equal to 2 times cosine squared of alpha plus beta divided by 2. I can now also factor this guy. And once I factor it, I will get 4 times the quantity AD plus BC squared. Now, if I rewrite everything again, I get 16A squared is equal to 4 times the quantity AD plus BC squared. Then I'm going to move this last part that we've been kind of neglecting up here. And then we'll have minus 8ABCD times 2 times cosine squared of alpha plus beta divided by 2. Now, if you notice, this is a difference of squares, so we can take advantage of that formula, and we will get two times AD plus BC minus A squared plus B squared plus C squared minus D squared, all times 2 times AD plus BC plus A squared minus B squared minus C squared plus D squared. And then we can simplify the last piece to be minus 16 ABCD cosine squared of alpha plus beta divided by 2. Now, if you notice, if we divide that 16 ABCD cosine squared piece by 16, it looks a lot like the last part of Bretschneider's formula, so we know we're on the right track. Okay, so now if I distribute the 2 in for both of these and rearrange a little to get like terms all clumped together, I get B squared plus 2BC plus C squared minus A squared minus 2AD plus D squared. Now, I just pulled a negative out of all of those terms, so it's a little easier for me to factor. And I will do it to the other side as well. And I get A squared plus 2AD plus D squared minus B squared minus 2BC plus C squared on this side. And I'm still going to carry down this last piece. Now, if I factor these pieces that I have in the parentheses within the brackets, this first one becomes B plus C squared. Second one is A minus D squared. And then in the next bracket, I will have A plus D squared minus B minus C squared. And still, I am carrying down this piece. So now once again, we can use the difference of squares, but in 2 places this time. And we get 16A squared is equal to negative A plus B plus C plus D And then I'll get A plus B plus C minus D from the first bracket. And from the second bracket, I will get A minus B plus C plus D and A plus B minus C plus D. And then I'm still bringing down this last piece. So now if you look down to the additional important calculations on the bottom left-hand side, you might see some similar things in the equation we just got. So I can rewrite some things, and this will be the first time I'm working in that semi-perimeter S. So when I rewrite things, I will get 16a squared is equal to 2 times S minus A times 2 times S minus D times 2 times S minus B times 2 times S minus C. And then I'm still bringing down this last piece. Almost done. I will bring the 16a squared down, and then 2 times 2 times 2 times 2 gives me 16, and I can just rewrite everything in order. And then minus the 16 ABCD cosine squared of alpha plus beta divided by 2. Now, if you notice, what we have is almost exactly what Bretschneider's formula is, but we need to get rid of the 16s. So if we divide this whole thing by 16, we get a squared equals S minus A times S minus B times S minus C times S minus D, all minus ABCD times the cosine squared of alpha plus beta divided by 2. And then finally, to get our formula, we just take the square root of everything. So we get A equals the square root of all of this. And we have exactly what the formula is. So we just derived Bretschneider's formula. So down here I have an example of how to apply Bretschneider's formula. So say we have a square with side length x. Using our regular geometry knowledge, we know that the area of this square would be x squared. So let's apply Bretschneider's formula and see if it agrees. So since all 4 of our sides are equal to x, we have A equals B equals C equals D equals x. So for our semi-perimeter, we would have 4x divided by 2, or 2x. Then we can figure out all of our S minus A, S minus B, and so on. So they will all also be the same. So we have S minus A equals S minus B equals S minus C equals S minus D, which will all be 2x minus x, or just x. For the angles, they're all the same. So alpha would be 90 degrees and beta would be 90 degrees. then we can figure out what alpha plus beta divided by 2 is, which would be 90 plus 90 divided by 2, or in other words, just 90 degrees. And then the cosine of 90 degrees is equal to 0. So if we plug all of this information into our formula, we get x times x times x times x, or x to the fourth, minus x times x times x times x, or x to the fourth, times the cosine of alpha minus squared of alpha minus beta over 2, which is just 0. So then we can simplify. We get the square root of x to the fourth, or x squared. Once again, my name is Gabrielle Clark, and thank you for watching my senior project video about Bretschneider's formula.